The second part of the exercise, the multi-word search, is a much more complicated thing to do. Why? Because this multi-word search has to essentially execute a statement similar to that one that we had just before the break, but it has to execute this statement multiple times. We will not get a single filter as we see it here, but we will get multiple filters. So what we essentially do is we have to take every word from the filter and execute a similar SQL statement over and over and over and over again. Then we have to count how many of the words can be found inside of the result, and based on the resulting count we have to order the result, right? Now what we could do is we could do the loop over all the filter criteria in C#, then do the aggregation in C# and everything is fine. But then again, we have the problem that we have to download nearly the entire database into our web server, and on the web server we need a lot of CPU power. So we have to transfer a lot of data from the database server over the network to the web server, and that takes a lot of time. What we want to do in such cases is we want to bring the algorithm down to the data and not the data to the algorithm. So we want to write a more complicated SQL query and trust the database that it is intelligent enough to perform what it has to do. But the first problem that we have to solve is how can we pass in multiple filter criteria into a SQL query. We don't have a string. We don't have a string with comma separated. We couldn't split it up in SQL. That would not be a good idea. Yes, you could use Google, but what is your search criteria for Google?
Multiple search criteria.
You will not be successful with this query. The correct term is table valued parameters. In short, TVPs. Table valued parameters are a great way to pass in not just one criteria, but a table in memory, a table of things which can be used inside of the query or insert or update or delete statement. Super powerful mechanism. It's available in many databases, not just SQL Server, and you should definitely remember this word, table valued parameter, right? Now let me show you how table valued parameters work. I've prepared that for you. In order to use table valued parameter, you need to create a type inside the database. Create type. This is not a table, it's just a type. It's like defining a class in SQL, but this time you create a type. And this type is created as table. That means we can insert many rows inside of the table type, and we can also add multiple columns. In our case, it's simple. We can stick with a single column here. You have a question?
Is this something SQL Server specific or?
What you see here is SQL Server specific, but it is supported in many databases. So you have to Google it with your specific database server. Maybe you Google for table valued parameters and then add Postgres or whatever. I guess very simple databases like SQLite, they will probably not support that. Maybe they do. I'm not an SQLite expert. And I guess very powerful databases, I also guess Postgres, could maybe support it.
I just looked it up.
And?
It's very similar. It's also created by.
Good, good. Yeah, okay, very good, very good. So we need to create a type. And then when we create a variable, we can specify that this variable isn't a string or an int or any kind of other type like date or time, but we can specify that the variable is in fact a table. Understand what I mean? This is why we call it the table type. The type is a table. It's not a table stored in the database, it's an in-memory table. Understand what I mean? And then, if you closely take a look, you will see that we can really insert rows into this in-memory table. We can treat it like a table. And when you take a look here at the query, we can also query the thing like a table. Understand what I mean? Again, this is called table valued parameter, because we specify a parameter value in the form of a table. And with that, we can easily pass in multiple search criteria. So this is a general tool that you can now remember, and it will come in handy, I'm pretty sure, at some situations in your future career. Okay, next one. The query that I created for you isn't the simplest one on earth. So if you take a look, the query starts here in line 24, and it goes down to line 54. It might contain some things which you have never heard of before. Maybe, I don't know. Tell me, I'm curious. Have you ever used a with clause in SQL before? Have you learned that in database courses? This is part of the SQL standard. It's not something which is SQL specific. The with clause is a kind of structured programming for SQL. What you can do is you can create a SQL statement, give this SQL statement a name, and in the next run, if we take a look here, we can use the with the defined SQL query using its name. So it is easier to use nested SQL statements. You do not need sub-SQL statements. You simply say, let's take this intermediate result and then create another SQL statement and build on top of that. And again, you can give this thing a name, and then the next step, you can again refer to this statement, to this SQL query that you defined up here. Understand what I mean? Just like a helper variable in a C# class. If you do a very complicated mathematical formula, then you might split it up into subparts, store them in intermediate variables, and then build the entire formula at the bottom. And exactly the same is done with a with clause. So make the basic statement first, then a statement which is based on top of the basic statement, then a basic statement which is, you get the idea. Understand? And now, a very important thing, we will not do that. We will do that if we would do a database course. These with clauses can even be recursive. You could query recursive structures. So for instance, if you have a user group which can be a member of a user group, so you have a recursive structures, user groups are members of user groups, and you want to find out in a single SQL query whether a certain user group is directly or indirectly a member of another user group, you can do that in a single query using a with clause. Or if you have products which are a part of another product, which are a part of another product, you can use a with clause to query such product hierarchies or employee hierarchies. An employee is a manager of an employee is a manager of an employee, and you want to find out all the employees which are directly or indirectly subordinates of a given manager. You can do that with a single SQL query using the with clause. Okay? The term for that is a common table expression, or in short, CTE. So if you want to have a Google search term, Google for common table expression, CTE, and you will find lots and lots and lots of results, of interesting results. And what I did here is I simply used these CTEs to first here count the number of hits that I have on each offering, and that is the third thing that you might never have seen before, cross-joined with the filters. You might have heard about an inner join. Did you? You might have heard about a left outer or right outer or full outer join, right? Have you ever heard about a cross-join? A cross-join is a Cartesian product between two different tables. So you essentially take every offering and you multiply every offering for every entry in the filter criteria. So if we have two filter criteria, we simply get every offering 2 times, combined with every filter criteria. If we have 5 filter criteria, we get every offering 5 times. Offer, criteria 1. Offer, criteria 2. Offer, criteria 3. Understand what I mean? This is a cross join, a Cartesian product between 2 tables. Again, it comes in pretty often, pretty handy. And by cross joining it, I have the possibility to check each filter criteria with each offering. And the result can be either 1, yes, this criteria is available in this offer, or the result can be 0. No, this filter criteria is not applicable to this offer. Understand what I mean? So if we, oops, what did I do? Okay, so if we try to sketch that, imagine that we have 3 offers. Offer 1, offer 2, and offer 3. Imagine, in green, that we have 2 filters, chair and plastic. Now the cross join will give us 1 combined with chair, 1 combined with plastic. That's the offer. The 1 is the offer, okay? 2 with chair and 2 with plastic. And 3, and I think you now get the point, right? And now I can use every single line and check whether 1 and chair is available. So I do exactly what we did before by using the like statements. Understand what I mean? So the result at the end of the day will be, for the first line, maybe yes, this is available. Plastic, no, it is not available. Chair, yes. Here, also yes. And I think you get now the point. And the last step is now that we aggregate here for all the orders the total sum of matches. Get the idea? So the total sum of match here would be just 1. The sum of here for 2, that would be 2. And this is done in the second query. Let me show you the second query. Here, I'm aggregating it. I'm filtering all the things which are never found. And at the end, I'm just ordering it. Got the idea? Pretty powerful what we can do in SQL, isn't it? With table-valued parameters and a little bit of SQL magic, we can do all the things in a single SQL query. You couldn't do that in Link. At least I don't know how. Do you have questions so far? We could now easily take this query here and perform exactly the steps that we had before. So we could take it, we could put it into a method, we can pass in the parameters. That's not a problem. We already practiced that. I think you understood the point here. We have another problem. And this problem is pretty hard to solve if you don't know how. Our problem is this. We need to create the type. How did we create the tables? Yep. I meant with which command? How did we really create the tables in the database? What did you do? Yeah?
.NET EF.
Exactly, .NET EF database update. Correct, exactly, that's it. But how should we tell .NET EF database update to create a type? There is no representation of this type in C#. We cannot create a class and then expect it to understand that this class should suddenly not become a table, but it should become a type. That's not possible. Have an idea?
Maybe manually add it to the migrations.
Exactly. And that is exactly why I added that to the homework. I want you to understand what a migration really is. And in this use case, we need to manually define a custom migration where we need to write the create type statement. Now we will understand what migrations really are. And this is what we are going to do together. So please go into your solution. And together we are going to create a new migration. So please, just to make sure, rebuild the solution. Make sure that your solution builds, okay? Make sure that you don't have errors. Make sure that the application really builds. When you did that, go into the developer command prompt and just create a new migration. Don't forget to go into the data project. You need to be in the data project, not in the web API project, because we stored our migrations in the data project. This is important, okay? And then we say .NET EF migrations add, and I will call it create type. So if you want to do that, just go for it. .NET EF migrations add create type.
Did you change something?
No, no, absolutely nothing. Absolutely nothing. We will just say .NET EF migrations add create type. The point is that we end up with a create type migration. You see it here, that just contains this filter offers. But we don't need a table for that. So we can simply, and that's the point, delete the entire content of the migration. So we created a migration, but we do not want Entity Framework to do the migration for us. It's our job to create the migration. So far, we relied on Entity Framework to generate the required code for ourselves. But this time we write it. Please note that the generated create type migration is a partial class. See that one? What I typically do is I keep the migrations in this folder, I keep them clean. I do not add code here. But because this is a partial class, I can create the same class again, but outside of the migrations folder. A partial class means that it is a class which lives in multiple files. Understand what I mean? So what I did here in this create type is I deleted everything. And I will just copy this guy, this one, the empty one, and create a new class, and I will call it create type migration. And here I paste in the thing that I just copied. And I will use the new feature of putting it here at the beginning and removing these curly braces. But that's just me, that's my programming style. If you don't like that, that's perfectly fine. Oops. This is what I want to do. Now we need to write the migration code. It's really not complicated. Yeah, question. Sorry.
You added the file to the migrations folder.
No, I did not, consciously not add the file to the migrations folder. I added the file outside of the migrations folder. This is again just programming style. I asked a good friend of mine who does a lot of work with Entity Framework whether he writes the code inside of the migrations folder or outside of the migrations folder. And he, for instance, told me that he usually does it inside of the migrations folder if he has to write custom migrations. So it's a matter of style. Decide on your own. You're old enough. You're old enough to make those decisions on your own. I personally put it outside. Okay. Now we have two important methods in a migration. One is called up, so override up. And one is called down, override down. Maybe you can guess from the context what up and down do. Up is performed when you database update something. And you might not have known so far that it's also possible to uninstall a migration from a database. So if you accidentally perform the database update on a production database, and you might find out, oh my God, there was a bug in this update, the migration was wrong, then it is possible with .NET EF to downgrade to a previous migration state. So up is executed when doing the upgrade, and down is executed when doing the downgrade. For a table, the up would be a create table, the down would be a drop table. For a column, the up would be adding a column to a table, the down would be removing the column from the table. Got it? And what is it, what we need? Well, that's simple. This will be the up, and this will be the down. Understand what I mean? Let's try it. So in the up, we simply say migration builder .SQL. There is just a statement here. And for simple cases, you just specify the SQL statement. And if you want, you can copy it from my GitHub repo. You do not need the semicolon at the end, but you can also keep it. Again, programming style. And that's all we need to do. Create the type when doing the migration up. And the down, well, not difficult, is it? Migration builder SQL. And for the down, we simply do the drop type. And voila, we have written our first custom migration. This is what migrations really are. Generated, create, drop, alter statements. Can you remember that we frequently in the past added this NuGet package to our entity framework projects? That's entity framework core design thing. This design NuGet package has the necessary code in it to generate those migrations with the up and down when looking at your classes. So it inspects your classes and generates something similar to what you see here, but for create tables. Understood what I mean? If you don't want to use this design NuGet package, you can work without it. But you have to write the create table statements on your own. Have fun. Understand what I mean? For some projects, this is really done. So I know product teams who do not want to rely on the generated code from Entity Framework. They say we are smarter. We have decades of database experience. We write the create table statements on our own, exactly as we want them to be. I would not do that. I would rely on the design functionality as long as I can and only write custom migrations when I really need to go for it. The last thing that we need to do in order to make all this stuff work is we have to go into the database fixture class of our tests and change this ensure created. Because you have to understand that ensure created is a really dumb way of creating a database. Because ensure created will only perform the create table statements. It will not really execute the migrations. We have to change it to migrate. Migrate, instead of ensure created, will really create the database by executing all the migrations. And then the easiest way of trying whether you messed up or whether it works is, once it has successfully been built, run the unit tests. Let me quickly check if it works, and then I will come to you and we will take a look. You see, the database tests still work, and if I go into my Data Studio, let me quickly check. Here we have our test database, programmability, types, user-defined table types. Whoa, here it is, you see? This was exactly what I wanted to prove. The filter tags type is there, and now I can show you another secret of Entity Framework. the migrations that have been executed are stored in a separate table. It's called EF migrations history. So if you take a look at this table, you should, if you did everything correctly, you should see your custom migration and you should see that it was executed successfully. This is what should have happened. So now I can help you overcome any problems. Please try it and make sure that it works. So who needs help? Gentlemen, we have 10 minutes left after solving some problems, and I think it worked. So let's spend this last 10 minutes to achieve really a solution we want to see the results of our hard work. So what we need to do is we need to specify, and we will copy this thing, from the offering search. You need to copy my implementation of the multi-word search, and it contains also the complex SQL query. This is not a database course, so we will not dive any deeper into the SQL statement. I described a little bit what CTEs are and so on, so that should be enough for today. We can go into our offering search, and by the way, of course the code is available on GitHub, so if you feel lost or if you couldn't follow along, no problem. You see, now we have this multi-word search. And let me describe the last thing of today's lesson. How can we do a table valued parameter inside of C#? And the solution for that is this class. If we want to pass in a table as a parameter, we need to specify and create a data table. That is the class, that is the C#, the C# end of a table valued parameter. And then we can specify this filter table as a parameter to the SQL statement. See it? This is how you pass in a table valued parameter. I will repeat that consciously. A table valued parameter. In short, parameter. In short, the TVP. This is what you should remember. This is how we pass in a TVP. Now, if you want to give it a try, it's really not complicated because you can go into the program.cs and simply copy the thing that we already have. Maybe let's call it multi-search. And here we do the multi-word search SQL. Understood? Really a one-liner, because now we have the entire code inside of our searcher. Finally, give it a try. Don't forget to update your test database. So don't forget to go into the terminal, go into the Web API project and do the .NET EF database update. That will deploy the migration to your production database, not your test database, but this time your production database. If everything works smoothly, you should see an output like applying migration create type. And if that was successful, you can run it, copy the request, change it to multi-search, and maybe specify chair. I use the comma as a separator, okay? And plastic, you can use the space or a semicolon, I don't care. And now let's see, are the demo gods smiling, yes or no?
Yeah.
Ah, I know what I did. I didn't do the splitting. I'm sorry, here. We are not allowed to use the filter here. I have to do the filter.split. Sorry, I forgot that one. And of course, we are not allowed to use an empty string, but we need to do an empty array of string. See, that looks much better. I will show you the code in a second if you couldn't follow. And, come on, give me, yes. That looks good. Here we have chair, here we have wooden. You can try it, it really works. See? Split with a comma. Good. We are nearly at the end of the hour and we finally succeeded. And today we wrote a non-trivial web API with a really complicated backend written in a large and complicated SQL query. We learned more about what migrations really are. And we saw that these minimal APIs really come in handy when it comes to such simple web APIs. The backend isn't simple, but the web API is really simple. Now, what did you get from me? Let me summarize that. In the where is it? In the GitHub repository, you have a solution for this week's homework where you have the entire solution that we developed together, but with even more features. With the sample solution that I provided, you also have unit tests for the single word search and the multi-word search. And these unit tests reflect exactly the specification of the homework. So take a look at this one. And I also gave you an Angular UI in which you see how to use reactive extensions, RxJS, the topic of last week, to query our multi-word search. So if you want to give that a try, run the Angular application and you are good. So you have a complete solution with the backend, with the API, and the Angular application. Okay? So you see, the fifth class is a little bit different than the fourth class. We didn't discuss a lot of the things that we had today, but now you are becoming more and more experts. Yeah? This is not the trivial stuff anymore. This is advanced entity framework stuff. And yeah, I think bad request. I will take a look at your code immediately, but we are 2 minutes before the end of the lesson, so we had a good timing. Thank you very much for the lesson this week. Unfortunately, I didn't find the time to come up with a new homework this week. I'm so sorry. I will find the time next week, okay? So this week I don't have homework for you. Next week I will come up with a new homework. Thank you very much. See you next week.